Hi everyone, Mrs. Below here. In this video, I'm going to be finishing up the scientific method notes. So again, previously we were talking about the steps of the scientific method, beginning with observations, asking a question. You see something, smell something, hear something. Maybe you collect some data in the form of qualitative or quantitative, and from that you hopefully answer your question in the form of a hypothesis, something that you can test through an experiment and either support or reject your hypothesis. Again, the independent variable is what you're going to manipulate in the experiment. The dependent variable is what you're going to measure. The controlled variables or variables what you're going to keep constant or the same throughout the entire experiment. And the experimental group would get the independent variable while the control group doesn't get the independent variable. Went over an example here. All right, so models. Once a hypothesis has been tested enough, it's usually not just one time and you prove something, okay? It's usually multiple times, usually more than one person is involved. But after many tests and collecting enough data, a model can be developed. So a model explains a phenomenon. So a model is something that is going to help us explain what we're seeing or observing and how data or events are related. So if a model consistently explains a phenomenon, it can become part of a theory. Again, people use this in everyday language like, oh, it's just a theory, but in science, a theory has lots of supporting lines of evidence. For example, in this class, we're going to talk about the atomic model for matter, so an atom. That has been revised multiple times over the years based on data that we've collected. So it's really important to remember that models and theories can change over time if we collect more data. So again, a theory is hypothesis or hypotheses can be supported or rejected and changed. Again, I said that earlier. And if a hypothesis is tested enough and has many lines of supporting evidence, it can become a theory. So again, you need a lot of evidence, okay? You need a lot of data to support that theory. So a theory is a broad generalization. So theories explain, okay? So a theory is something that's going to explain a phenomenon. So it's like theory of gravity, okay? Explains why things fall to Earth. So a theory has a lot of supporting evidence that helps us to explain the world around us. And again, here's the big picture. We start with observing, collecting data, measuring, maybe asking questions. From there, hopefully we answer our question in the form of a hypothesis or hypotheses. And it has to be something that can be tested. So it's testable. It can be written in the if-then statement. If I do this, then this will happen. And then we test, we experiment. And again, you can go back and forth between these steps. Maybe you don't come up with a good enough experiment. You have to kind of go back to the drawing board. It's not testing what you want. Maybe you need to revise your hypothesis based on the data that you collected. But if you do this enough, and eventually you can get to creating models and creating theory. Again, this has to be done by a lot of testing to support that evidence. And then typically results will be published and communicated to other scientists. a lot of times when work is published, it has to be peer reviewed. So there's other people that will review it, the work, and or like recreate the test themselves to make sure that, you know, that person wasn't just making up their results. The last thing I want to talk about is relationships. We're going to talk a lot about these throughout the entire year. This will come up again and again, so it's important to understand. So if you have a relationship where as one variable increases, so earlier we were talking about the plants, so the growth of the plants increased over time, okay, with that changing of the percentages. That could be an example, or, you know, something else increases as something else also increases. So as one variable increases, so does the other. As one variable decreases, so does the other. So if these two variables have that relationship, they are directly proportional. So mathematically speaking, to each other, if dividing one by the other gives a constant value. Constants will come up a lot in this unit. They're numbers that have already been tested and discovered by scientists. And that relationship, a direct relationship, will look like this on a graph. So for example, if you're talking about mass and volume of aluminum, this line represents the density, which is constant or the same. So this line right here, it's a completely straight line. That's also what we do like to see when we are doing experiments and things like that. That could be a good indication that the data you're collecting is accurate and good. But this line right here would represent the density of aluminum, because as the mass and volume both increase, they're increasing proportionally to each other. So we can look at that on a graph like this, or we could look at it on a table like this. So you can see as the mass is going up, the volume is also going up proportionally. And if you divide those by each other, notice that that number is pretty much staying the same. So that would be a direct relationship. So an inverse relationship then is the opposite of that. So this is when as one variable increases, the other decreases. So here you can see as this variable is decreasing, this variable is increasing. So these are inversely proportional. So this is when as one variable goes up, the other goes down proportionally. Again, we like to see a direct, it be proportional to each other. Sometimes that happens, sometimes it doesn't, depending on the data you collect. But here, so this is volume and pressure. This is later when we get to chapter 11 next semester. You could see as the volume is going down, the pressure is going up. So you can see that here. Look, as the pressure is going up, the volume is doing the opposite and it's going down. So this is an inverse relationship. And again, if you were to proportional each other, if they're products, so if we multiply them together, is constant. So if we do the pressure times the volume, then we're seeing pretty much the same number the entire time. And this is the case if the temperature is kept constant. And then that was also the case up here where the temperature was also being kept constant. So those would be examples of controlled variables.